In this video, we're going to be tackling this really hard recursion problem from Purple Comet. You can tile a 2x5 grid of squares using any combination of 3 types of tiles. Single unit squares, 2 side-by-side unit squares, and 3 unit squares in the shape of an L. The diagram below shows the grid, the available tile shapes, and one way to tile the grid. In how many ways can this grid be tiled? So, the best way to solve these kinds of problems is to use recursion. So let's define A of n here. A of n is equal to number of ways to tile 2x n grid using these 3 shapes. So we're trying to find A of 5. Okay, and so well, let's do cases. So case 1 is if it's a single we can look at this top corner right here. Case 1 is if there's a single unit square right there. Case 2 is if there's a 2x2, if there's a 2x1 right there. Case 3 is if there's a 2x1 like that. Case 4 is if there's a 3x1 like that. Case 5 is there's a 3x1 like that. In case 6, as if there's a 3x1 like that. Okay, so the good thing about these cases is that every single tiling falls into one of these categories. So at the end, we can sum them up into a recursion. Let's start with case 1. Right away, we notice the problem. There's no way to express that in terms of A of n minus 1 or A of n minus 2 because we have an odd one out. So let's define a new recursion. B of n is equal to number of ways to tile 2x n grid without 1 square, 1 top left square using these 3 shapes. So B of n is the number of ways to tile a 2x n grid without 1 top left square using these 3 shapes. So this simply B. So this is just cases for A of n. Not specifically A of 4, because we're going to generalize this. So this would just be, for case 1, just going to be B of n ways, because that's A of n. That's literally the definition. Okay. Now let's go to 2. 2, that's also pretty simple. It's basically just A of n minus 1 ways to tile the remaining. 3, okay, so 3, it's a special time where we have to split this up into more subcases. So 3, so we can define 3A to be when it's like that, and there's a unit square there, and 3B is when it's like that. So 3A, it's just going to be B of n minus 1, and 3B, it's just going to be A of n minus 2. That should be pretty clear. So 3 would just, for case 3, it's going to be A of n, B of n minus 1 plus a of n minus 2. About case 4. So that's basically the same thing as this. So it's just b of n minus 1. Since these are unnecessary, you can start clearing them to make more space. Okay, for case 5 and 6. For case 5, it's going to be basically, for case 5, basically, that's still b of n. It's not one top left square, but rather one bottom left square. But by symmetry, the number of ways to tell that will still be the same. So that's still b of n minus 1. 6. Okay, so here we know that this empty square right here, it must be filled in. So that's just a of n minus 2. Okay, that's good. So now we know that a of n is equal to b of n plus a of n minus 1 plus b of n minus 1 plus a of n minus 2. Just clear this to make more space. B of plus b of n minus 1 plus b of n minus 1 plus a of n minus 2. Okay, so now you can check that makes sense because it's just the sum of these separate cases. B of n, b of n. Yeah, okay. So now, so that's a formula. Okay, now, but what's b of n? We also need a recursive sequence for b of n now. So let's do the same thing, cases for b of n. Okay, so b of n, be shaped like this. So on. But, so the first case is if there's just a L shape like that. Second case is if there's just a 1 there. In the third case, is if there's a 2 right there. See that this is all the possible cases that contain that, because the 1 by 1, and there's that L, and there's that 2. So basically, so we can also derive that this case 1 has, let's see, so that's just that's just a of n minus 2 ways. And case 2 would be a of n minus 1. Case 3 would be b of n minus 1. Because that, yeah. Okay, so then we can put that down here. Summing up the cases, we'll get b of n is equal to a of n minus 2 plus a of n minus 1 plus b of n minus 1. Okay, let's simplify some of these. Now, we don't need any of this anymore. So from now, it's purely algebraic manipulation. And we can create a table to help us find a of 5. So let's just simplify that. A of n is equal to, so let's combine these 3 terms. 3b of n minus 1. Let's combine these 2 terms. 2a of n minus 2. Let's combine, let's see. We can't combine anything else, so we can just write those down like that. Okay, so now let's see. We know that a of n minus... Okay, so now let's substitute this into here because we can rewrite a of n as, if we split out some things, we can rewrite it as because that summing together is essentially the same exact thing. Okay, so now that we have that, let's plug this into here. So then we'll get a of n is equal to b of n plus a of n minus 2 plus b of n minus 1 plus b of n. So a of n is equal to 2b of n plus a n minus 2 plus b of n minus 1. Okay, so now that we have those two formulas, let's move them up to here. A of n is equal to 2b of n plus a of n minus 2. However, notice that there's actually, here there's actually 2, so. We can rewrite that as 2 times b of n plus b of n minus 1 plus a of n minus 2. Okay, now b of n, that's going to be a of n minus 2 plus a of n minus 1 plus b of n minus 1. Okay, so that's all we need to solve the problem. So let's quickly make some base cases. So obviously, a of 1 is equal to 2. There's 2 ways to tile a 1 by 2. You have like that separately, or you just have it together. So let's make a table. So it's a of n, b of n, numbers 1, 2, 3, 4, 5. Shouldn't need to go past 5 because we're trying to find a of 5. Okay, so we know that a of 1 is 2 and b of 1 would just be 1 square, so it's just 1. And to get started, we need to know that b of need to know that b of 2 is going to be, so that's one way, or you can, there's 4 ways to tile that. Okay, and now we can just plug this into the formula. So to find a of 2, it's going to be 2 times, it's going to be 10 plus 12. Actually, it's going to be 10, and then we'll just let a of 0 be equal to 1. So then this would be 2 times 4 plus 1 plus 1. So then that's just going to be 11. And so this just be b of 3 is equal to 4 plus 11 plus 2 is equal to 17. So then a of 3 is going to be equal to it's 2 times b to the n, so it's 34, plus, and then 2 b of n minus 1, so it's plus 8, plus 2, so that's going to be 44. Okay, so then b of 4, we're getting close. B of 4, that's equal to 55 plus 17, which is 72. Okay, and a of 4 is equal to 11 plus 144 plus 34, which is equal to 11 plus 178, which is equal to 189. So then b of 5 is going to be equal to, so that's just 189 plus, so that's going to be 305. So then our final answer is going to be 610 plus 144 plus 44. 610 plus 188, which is 798. 798 is our final answer after all of this work. Just going to confirm that. Yeah, because that final step was just a of 5 equal to 2 times 305 plus 72 plus 44. It's going to be 610 plus 144 is 44, which is going to be 610 plus 188, which is 798. So that concludes this problem. So note that this was a very hard problem. On Amy, if it were on Amy, it'd probably be like a problem 12 or 13, in my opinion. So that's it. And if you like this video, please subscribe and comment your ideas on this problem or what problem you want me to do next. Okay, that's it. Bye.